so I'm gonna grab the worksheet and kind of work off of it with you for the front. We'll just remind ourselves what perimeter and area mean. We're doing them with polynomials. That's a fun change. So the first one starts off kind of basic, right? So you just have a nice little rectangle. Your guys have printed out, or if you have it. We see the base is 4x plus 3. We see the height is 2x plus 2. And it says, hey, can you find the perimeter and the area? And I'll say, sure I can. So we just need to remind myself, how do we find the perimeter of any object? So the perimeter is we find the sum of the sides, aka we add up all the sides. Yes?
It's not 2x plus 3, it's 2x plus 2.
Oh my gosh, thank you, because I would have been so mad if I did it wrong. Always call me out if I write something wrong. Thank you very much. That saves me from doing this one correct way. So perimeter means I just need to add up all my sides. I find the sum of all the sides. So the big thing here is just labeling. Just remind yourself, hey, I'll tell you the biggest mistake is people just add this with this. That's not the answer. The answer is I need to add this with this, and I need to add this side, and I need to add that side. So I need to go all the way around. We do have a rectangle, so it's nice because if I have this side, then that's just a nice little mirror image. So that's also 4x plus 3. And if I have this side, then that kind of mirrors over here. So the first thing I usually do for these problems is I just make sure all of my sides are filled in, just to remind myself, okay, when I'm doing perimeter, I need to add everything. So let's add them up. So we can kind of go through it. I just kind of remember where you start and just kind of go around. And when we're adding, we're just combining like terms. That's what we're always doing with polynomials. Hello, welcome, come on in. We're using that worksheet right there in that front bin. If you wanted to grab that.
Let's grab it.
Fabulous. So we're just gonna follow on, just make sure you know where you're starting, right? I'm gonna start here. So I have 4x plus 2x, what's that, 6x, plus 4x is 10x, plus 2x is 12x. So even if you circle, just so you remind yourself, you're not repeating a sign, and I'll get 12x. So wherever you please, Mrs. Thank you.
This is the math I remember well.
Oh, yay.
I was like, I can do this.
Even better. So now go around and combine your constants. Once again, just kind of keep yourself organized. So I have 3 plus 2 is 5, plus 3 is 13, plus 2 is 15.
Wait,
But
3, 4, 5, 6, 7, 8.
I totally added that.
Yeah.
Oh, Mrs. Sherman, that would just be 10.
Hey.
What a day. I was adding an extra 5 in there. And that would just be your perimeter. So usually when we find perimeter, you think of like, oh, I want like a number. For us, since we're just adding polynomials, your answer will be a polynomial. Hey, does anyone remember what would the name of this be? Yeah.
It's a linear. A linear.
Just say that. Throw it.
Binomial.
Remember, you need to know those names for tomorrow, guys. So we'll just throw them in today just to keep reminding ourselves of them. I think tomorrow it's just a matching section, so it shouldn't be too bad if you kind of have a general idea. But those are something I would look over if I were you. Okay, so now let's find the area. And for the area of a rectangle, we just do length times width, base times height, whatever you want to call it. So we're just multiplying. So I'm just going to do my work kind of right under here. This side, which is 4x plus 3, times this side, which is 2x plus 2. So with perimeter, you needed all 4. With area, you just need the 2 sides, base and height or length and width, whatever you want to call it. And then we remind ourselves from last week, we are going to distribute this. So I take my first term, and I'm going to distribute it over. The big thing to be careful with, this is where I usually see the most mistakes, is when you're multiplying and you do 4x times 2x, a lot of people just write 8x. It's 8x squared. Remind yourself to put the 1s there and add those exponents. And then I distribute over, and I'll get plus 8x. And then with distributing, it's just however many terms you have is however many times you have to distribute. So I'm going to distribute this 3 as well. And I'll get plus 6x plus 6. And for my final area, which will be a polynomial, once again, we're not just getting like a nice value, We do need to combine like terms. So for my final area, I'm gonna have 8x squared. I can combine those two middle terms because they're alike. That would be plus 14x plus 6. Those would be my two answers. Let's remind ourselves of the name of this one. Can someone just yell it out, whether you're at home or whether you're here? If I have an exponent of 2, we call that the degree of 2. The name is quadratic. Beautiful. And then if there's 3 terms, it's a trinomial. So that's just starting to remind ourselves of those names, because we refer to them actually quite a lot throughout the rest of the year.
So,
Yes.
if I remember correctly, it's, if there's like a 6 as an exponent, it's like a.
You just say 6th degree.
Okay.
Yep. Yeah, so obviously there's only so many names we're gonna memorize. So for the degree, you can have a degree of 0, which is a constant. 1 was linear, 2 was quadratic, 3 was cubic. Those were kind of familiar with us. 4 was quartic, so we thought about quarter, and 5 was quintic. I was thinking about quintuplets, which is 5 maybe, so. And then after that, there's no really special names, 6th degree, 7th degree. And then for polynomials, it's just monomial, binomial, trinomial. And then after that, it's just a polynomial of 4 terms or 5 terms or whatever.
So if it did have an exponent of 6, it would be a
You just say a
6th
6th
degree
degree.
trinomial?
Yeah, something like
Okay.
that, exactly. So before we do the next one, so we started with kind of a basic one. If you're looking at number 2, you're like, oh, wait a second. There's like a few extra things going on there. So are there any questions with number 1 before we move on to number 2? Nothing, anything at home? I'll take that as a no. So I'm gonna take a second because I'm gonna draw mine. I want it to look beautiful like yours, but I hate projecting, so that's all blurry for the people at home.
You have such a beautiful handwriting.
Oh, thank you.
Oh my God, it's so legible.
I tried. All right, so we got a big old rectangle, and then we have another rectangle, and then we have another rectangle. That's looking beautiful. And we have a few sides. Once again, the sides are polynomials. Oh, I can't write sideways. 2x minus 3. That's going to have to write sideways. I'm just going to write it this way. 2x plus 1, and that's 2x plus 3. So we're doing the same thing we were just doing. So what I highly suggest you do when you see a problem like this is label every side before you start to do anything. Okay, so if there's a blank, I want to fill it in. So let's just kind of go around. Well, if this, I'm just going to start here. If this is 3x plus 2, then this is 3x plus 2. So I just kind of go around and like reflect it to the other side of the rectangle. If this is 2x minus 3, then this is 2x minus 3. So I just kind of go to where I know and then see if I can fill it in. If this is 2x plus 3, then this is 2x plus 3. And if this is 2x plus 1, all the way over here is 2x plus 1. All right, so everything's filled in, right? Because we just want the outside. I don't care about those inside things. It was more just to kind of visually see them split up. Sorry, I'm just checking how much room I have so people at home can see what I'm doing here. So we want to find the perimeter, which just means we want to find the distance around the shape. So just start somewhere. I like to circle just so I remember where I start, and I don't know, just so I don't go crazy here. So I'm going to start here. And I'm going to start with my x terms because I can only combine things that are alike. So let's start. 2x, and we're just adding all the way around. Plus 2x is 4x. Plus 2x is 6x. There's a lot of 2x's here. 6x. Plus 2x is 8x. Keep going around. Plus 3x is 11x. Plus 2x is 13x. Plus 3x is 16x. Plus 2x is 18x. Are we all good with 18?
Yep.
Half of the time it's me making a mistake, so thank you for helping me out there. So I just kind of go around, or if you wanted to write them all individually, kind of lined up, feel free to do so. I kind of like the circle method. It keeps me organized on my way around. And I'm good. I know I've got everything. So now let's do our constants. So start wherever. I'm going to start here. I like to underline in this case, so I know I got everything. So we have, oh gosh, is that a minus 3? Yeah. So we have 3 minus 3 is 0, okay? Plus 1 is 1. Plus 3 is 4. Plus 2 is 6. Plus 1 is 7. Plus 2 is 9. Minus 3 is 6. And then so we got everything. That was plus 6?
Yep.
Beautiful. Okay. Just want to make sure I stay organized there. So remember, your answer is a polynomial. So don't be like, I don't know what the answer is. If I gave you an x, you could plug it in, but your answer is a polynomial. You're good. Oh gosh, we gotta find the area of this bad boy. So let's see the area. That's why I kind of tried to split it up like this. Basically, if you want to find an area of a shape like this, you kind of have to do individual shapes, and then we'll kind of add the things together. So let's start in this rectangle. I'll actually just do the work right in here. So we want, what do you call it, length times width or base times height. We're going to multiply those two sides together. So let's just do the work right here. 2x plus 1 times 3x plus 2. So I'm going to multiply that out by distributing. So if I distribute the first term, remember the big one, 2x times 3x is 6x squared. And then distribute again, that gives me plus 4x. And then once again, if we have a binomial with 2 terms, then we have to distribute again. So that would be plus 3x plus 2. And I'm going to combine like terms while I'm here. And I'll get 6x squared plus 7x plus 2. Okay, so I'm just going to kind of do that to remind myself. I'm going to need that in a minute, but I'll find my other triangles. I'm in trig mode. Other rectangles. All right. So because we still got 2 rectangles to go, guys. So now we need to find the area of this. And we say, okay, well, I can find the area of that. I'm going to multiply that 2x plus 3 times the 2x plus 1. Everything when we're multiplying is distributing with polynomials, so I just start. So that gives me 4x squared. That gives me 2x. Distribute my second term is 6x plus 3. And let's combine like terms while we're here and kind of take care of that simplifying. And we'll get 4x squared plus 8x plus 3. All right, I'm going to kind of do that once again. Most of this is just kind of staying organized. All right. Last but not least, we have one more rectangle, so let's multiply this out. We have 2x plus 3 times 2x minus 3. And let's do our distributing. Once again, once you kind of get these down, you're just doing the same thing every time. We're just changing some numbers. Minus 6x, and that would be plus 6x minus 9. And what I notice for this one is my middle terms, when I go to combine them, negative 6 plus 6 is going to cancel. I'm just left with 4x squared minus 9. All right. So we need to find the area of this whole thing. So we find the area of individual pieces. So to find the complete area, we're just going to add those together. So I'll just kind of do my work over here. I have 6x squared plus 7x plus 2 plus my other rectangle was 4x squared plus 8x plus 3 plus my last section was 4x squared minus 9. I'm just going to check to make sure I'm still on the screen for the people at home. Oh yeah, I got plenty of room. All right, let's combine like terms and then we'll be done. Let's see what we've got. So reminder, like terms is if I have an x squared, I can only combine it with other things that have x squared. So I'm always an underliner to try to organize. And when I'm adding, I just add the coefficients. You do not touch the exponents, so please be careful. So 6 plus 4 plus 4 will give me 14x squared. So you don't change the exponent with addition or subtraction. Now let's do the x's. We got 7x, 8x, and that was it, right? Because there's no x there. That's just 15x. And last but not least, our constants. We got a 2, we got a 3, we got a -9. What's that gonna be? 5 minus 9 is -4. And that, my friends, would be our final area of that lovely shape that was given to us. So I'll give you a second, because I know that was a lot of writing. I'm gonna kind of just check over here as well. So before we move on, once again, I'll give you another minute or two to get caught up, if you need to write anything. Does anyone have questions on that specific problem? Anyone at home? I'm just checking the chat. Nope, nothing in the chat, okay. So feel free at home, you can always throw on your mic too if you have a question. So it's all stuff we knew how to do, right? We know how to multiply, we know how to add. We know how to, you guys said you were familiar with perimeter and area from before. We're just adding in all that fun polynomial stuff. And once again, when you see something like that, you have to kind of do it in sections, so. Oh, this is just lining up beautifully. All right, so we're gonna do 3 together. We'll see if we can kind of figure out, it asks us to find the area of the shaded region, so it doesn't even ask for perimeter on that one. And then, 4 and 5 just looks so, look at those beautiful numbers. We have to find the GCF of them. That looks like it's gonna be fun as well. Okay, so let's do number 3. Does anyone still need number 2 before I erase it? Everyone good at home? Okay. Always yell if you need extra time. All right, number 3. What do we got? We got a big old rectangle. In our dimensions, we have 2x plus 4 and 3x plus 6. All right, and then we have a little rectangle inside. And we have 2 sides, 2x minus 1, 3x minus 1. And then this whole thing is kind of shaded in. And it says, can you find the area of just the shaded region? So does anyone have an idea, whether here or at home, what would I do? Michael?
I think you find a small box and like subtract it from after you found it in the box.
Perfect, exactly. So we're gonna find the area of the large rectangle, and then we want to just subtract out the area of the smaller triangle. So we have to do a few steps, obviously. We can't make it too easy on you. So let's kind of do one thing at a time. The big thing, just make sure you're labeling. Don't just start doing work and not know what you're finding. So I'm gonna say large. I'm gonna be lazy. I don't wanna write the word rectangle. You got the idea. So to find the area of the large rectangle, we've done this a few times already. We're gonna multiply, just length times width. 3x plus 6. And reminder, we're having a quiz tomorrow, and there's a section that's just on multiplying. So if you're understanding this, you're in good shape. If you don't, please let me know. I'm after school today as well. Let's multiply 3x squared. Remember, those both have exponents of 1 that we add. Let's see, plus 12x. You just kind of started to be getting into a groove with these, because you're really just doing the same thing every time. And let's always combine those like terms. Okay. So we got the large triangle. Oh, yes.
It would be 6x.
Oh my gosh, what did I do? Oh yeah, where did I get that 3? Thank you. I'm like, my Monday brain going on. Always yell at me if you see a mistake. Now let's do our small, that's an awkward rectangle, but you get the idea. So we're gonna multiply 3x minus 1 times 2x minus 1. What do we get? 6x squared. Okay, Mrs. Sherman, make sure you multiply correctly. Minus 3x. And then minus 2x plus 1 for a polynomial of 6x squared minus 5x plus 1. Delightful. Oh wait, I didn't change both of them. Oh gosh. There we go. So now we said, well, to find the area of just the shaded region, we're going to subtract those. So I'll just do it kind of right below here, so I'm not too far off on the side. So I have the large triangle, 6x squared plus 24x plus 24, minus the small I keep saying triangle, gosh. Sorry, I teach trig my first 2 periods and I got triangles on the brain. Rectangle. Be careful with subtraction. So we talked about this last week when we were practicing. What I always do with subtraction is I take my minus sign and I distribute it just to take care of my signs for me. So I'm not making silly mistakes later, because that always happens when we subtract. So now I can basically just combine these like terms. Ooh, the 6x squareds are going to cancel, right? You have a positive and negative. 24x plus 5x is 29x. And then 24 minus 1 would be 23. So this, my friends, would be the area of that shaded region. Once again, it's just a polynomial. So a few steps to get there. There's just kind of do one thing at a time. It's when people try to kind of like do a million steps at once that you get kind of messed up. So one thing at a time. That ended up being 3 steps. Any questions on number 3 or on anything with area and perimeter in general? I will warn you for this next part, you need a calculator. So I do have a few extra up here that have disinfected after this morning. I'm gonna grab mine, because there's no way we're gonna do this in our head. Because if you look at those numbers for numbers 4 and 5, they're looking a little big. Calculators are our friend. Oh, I'll bring it over to you. All right. So, any questions? Okay. So, in a few minutes, there are a few practice for you guys on the back, just to see if you have any questions. So, let's see how much time we have left. You can kind of practice a few. But let's look at this last kind of section. And just as a heads up for tomorrow's quiz, it's on the stuff we went over Friday. We kind of did a review day. We did adding, subtracting, distributing, multiplying. There are going to be 1 or 2 area perimeter problems on there, because that's just adding and multiplying. And this factoring out the GCF with the really big numbers, that's going to be an extra credit for now. You will have to do it, you will be responsible for it. But for tomorrow, it will be an extra credit problem. So still good to pay attention, because you're still going to need it. But just as a heads up for tomorrow. So number 4 looks so exciting. Okay, number 4. We want to find the GCF, greatest common factor, let me write it up, of this. Okay. We're not just guessing it, right? If it was like 7 and 14, we could probably do it off the top of our head. So this is where our calculator is going to be up right. We are going to do something called the prime factorization. You might have done, I don't know if you guys did this in the past. Did you guys ever do factor trees?
Yes.
Yeah, that's what we're just doing, a big old factor tree. So we're going to do a factor tree. So prime factorization, we want to get it down to all prime numbers. So I just start, I don't know, 50, 40. I literally start with 2's. I just go with it. Let's divide it by 2. It's 2 times 25, 20. I'm just going to keep dividing by 2's until I can't anymore. So that's 2 times 12, 60. Divide by 2. 2 times 6, 30. Oh man, we can keep going forever with this bad boy. Oh, 2 times 3, 15. Okay, I'm out of 2's, right? Because 315 isn't divisible by 2. I kind of go in order of my prime numbers. So it's 2, 3, 5, 7, 11, 13, all in order. So I'm going to do 3's next. I just like things in order, math teacher. This is divisible by 3. 3 times 105. So I literally just hit divided by 3. 3 times 35. Okay. Whew. 35 is not divisible by 3. No. 35 is divisible by 5. And then we're down to all primes. Bye, Mrs. Beach. Have a great day. All right, we're done, finally. Okay. So here's how I'm going to write it. Think of how many 2's I have. I have 1, 2, 3, 4. I'm going to write that as 2 to the 4th. Right, if I have 4 of them, it's 2 to the 4th. How many 3's do I have? I have 2 3's, so I'm going to write that as 3 squared. And then I have times 5 times 7. Okay. So I'm just going to keep that like that for now. Let's do our second one, and then we'll see what the heck we're looking for. But we call this the prime factorization. And I know we have x's and y's, we'll deal with those in a minute too. I like to focus on one thing at a time.
Is this gonna be on the test?
It is an extra credit on tomorrow's quiz. So, yeah, so if you're like, oh, I don't want to do this, it's not gonna hurt you, so it's fine. All right, let's start. I like, once again, see how it's like nice and order, like how beautiful is that? That's why I just like to start with twos. So I'm gonna start with 24,300, divided by 2, okay. 2 times 12,150. So I'm gonna keep with my twos. I like when things are in order. 2 times 6075, okay. That's all I got for twos, right? Because 6075 is not an even number. So I like to go to threes, and I like to do in the order of the prime numbers. Oh, this is divisible by 3. 3 times 2025. So once again, I just write this, and I say divided by 3. I have no clue if it is. It is. Ooh, excited. If you get a decimal, that's when it's not divisible. So if you get a decimal, it's out. Is that divisible by 3? Oh, it is. Man, a lot of threes. Is that divisible by 3? It is. Oh my gosh. Is that divisible by 3? It is. Is that divisible by 3? No, because it's 5 times 5. Okay. Oh. Doesn't it just look so nice though? It looks so beautiful. So let's write this out. 2, there's 2 2s, so we're going to write that as 2 squared. The threes, there's 1, 2, 3, 4, 5 of them. So that's 3 to the 5th. And then we have 5 squared. Ooh. So think about what we talked about with GCF. We said something was a greatest common factor when they had it in common. And if they have it in common, you take the one with the lower exponent. So think about this. You have 2 to the 4th. You have 2 squared. So they have a base of 2 in common. You take the one with the lower exponent. So I'm going to write 2 squared. You have 3 squared. You have 3 to the 5th. I take the one with the lower exponent, 3 squared. You have 5, or 5 to the 1st. And you have 5 squared. So the lower exponent would just be 5 to the 1st. And you have 7, and there's no 7 over here, so that's not a GCF. So this is going to be the number that is the GCF. So let's figure out what it is. What's 2 squared times, oops, if I hit the right buttons, that would be right, times 3 squared times 5? 180 is the GCF between those two numbers. Who'd have thunk it? But we're not done. Oh no, we're not done. Because there's variables. Just take that same idea. If we have x to the 3rd and we have x squared, we take the one with the lower exponent, x squared. If we have y to the 5th and we have y to the 3rd, we take the one with the lower exponent. So this is my greatest common factor, 180 x squared y to the 3rd. But we know we always divide it out of the original. So go back. I'm going to divide 50, 40 divided by 180 is 28. If I have x to the 3rd and I divide out x squared, I'd just be left with x. And if I have y to the 5th divided by y to the 3rd, that's y squared. 24,300 divided by 180 is 135. And then the x squares would cancel and the y to the 3rds would cancel. And after all that beautifulness, this would be my final answer. And we have a face of happiness because that was so fun. My eyeball's looking a little weird. There you go. There you go, guys. Whew. I actually once again, when you're a math teacher, you're just I actually enjoy doing that. I don't know why. But it doesn't look so nice. That's why I like doing it in order. If you just start with random factors, you can do that. You just need to make sure you kind of go back and know how many of each you have. So I always just got to go through my prime numbers. Is it divisible by 2, 3, 5, 7, 11, 13, 17, 23, 29? I don't know. There's a bunch of them. Usually I won't make them too big. Oh, that was so fun. Let's do another one. It was so fun. Let's do number 5. Oh, number 5 has. All Sorry, I make myself laugh. Just love math so much, can't help it. So let's just go through the process again. What we're doing is making a prime factorization, beautiful little factor tree with all the prime factors. We write it out in kind of exponential form because when you write it like that, you see what they have in common, and then that helps you get your GCF. So let's do 5. Now we have a few examples on the back for you guys to try if you're bored, you want to do it on your time, and if not, then we'll just see if there's any questions for tomorrow. Once again, there'll be one like this as a extra credit. Let me write it out first. Okay, so once again, I'm gonna go through, and I'm just gonna start with 2s. I like to go in order so it's organized. If you divide it by something and you get a decimal, it is not a factor. So you can't use it in the factor tree, so just as a reminder. Evens are easy to tell because you know if it's divisible by 2, but some of the other ones I just don't know. So let's start. That's gonna be definitely divisible by 2. 2 times 21,450, sounds good. So then I just kind of keep that in my calculator and I just hit divided by 2. And that's, that works, 2 times 10, 725. Right now I can pretty much tell this isn't divisible by 2 because it's not even. But if I wasn't paying attention and I put divided by 2, it gives me a decimal. So that's why I know it's not. So let's check 10, 725 and see if it's divisible by 3. I like to do my things in order. So let's do 3 times 35, 75. Okay. Let's see if that's divisible by 3. It's not. I put it in and it's a decimal. So 3 is out. So let's check 35, 75 and see if it's divisible by 5. 5 times 7, 15 it is. You can usually tell the 5s, right? Because they end in 5 or 0. So that's 5 times 143. Okay, 5s are done because we're not, it doesn't end in 5 or 0. So what's the next prime number? 7. It's not divisible by 7, so check a few. 11, it is divisible by 11. So I'm gonna write this as 2 squared, 3, right, there's only one 3. 5 squared, 11, 13. Okay, we have a few options here. Once you kind of get into the groove, I know it looks long, but it's really not. It's not terrible. Again, for a person that likes to organize things, this is kind of fun. Okay, so I'm gonna give myself a little room over here. So I have 141,570. I'm gonna start with my 2s. It is divisible by 2, but then I end up with 7785. I know that's not divisible by 2 because it's not even. So I'm gonna see, is that divisible by 3? And it is. Okay. So I just kind of keep checking. Is that divisible by 3? It is. Okay, well, good stuff. I don't know why it brings me joy when I can find a factor. Is that divisible by 3? It's not. Once again, I don't know that off the top of my head. I just put it in a calculator and it gave me a decimal. So I can't keep going. So 7865, that's definitely going to be divisible by 5. But if I divide by 5 again, that's not going to work either. Okay, so 5's out. What's next? Let's see if it's divisible by 7. It's not divisible by 7. Let's see if it's divisible by 11. Oh, it is. And then 143 is also divisible by 11 because it's 11 times 13. Woo! So I'm going to write that as 2. 3 squared, 5, 11 squared, 13. All right, I'm running out of room here. 390. Cha-cha. I'll just start here. I start with my 2s. I'm like a creature of habit. I'm going to do the same thing every time. 2 times 195. 195, is that divisible by 3? It is. 3 times 65. 65, that's not divisible by 3, but it is by 5. 5 times 13. So that would be 2 times 3 times 5 times 13. Whew. Let's see what our GCF is after all that. So I just kind of go through and do the 2s and the 3s and the whatever. 2 squared, 2, 2. So the lowest exponent is 2 to the first, right? So that's gonna be part of my GCF. 3 squared, 3. So they have the 3 in common, the lowest exponent is just to the first, so there's 3. 5 squared, 5, why did I write 15? Okay, sorry, going crazy today. 5 squared, 5, 5, okay, they all have a 5 in common. 11 squared, no 11, so 11 can't go in there. 13. So my GCF for the number would be a 2, a times a 3, a times a 5, a times a 13, 300, 390, is it? Oh, that's so precious, it was part of our original number. And then when I look for the A's, the lowest exponent is a to the 7th. So let's see what we'll get when we divide it out. 42,900 divided by 390 is 110. If I have a to the 11th, but I take out a to the 7th, remember you subtract those, that's a to the 4th. All right, second term, 141,570 divided by 390 is 363. If I have 8 but take 7 out, that's just a. And 390 divided by 390 is just 1. And a to the 7th would cancel out. All that work for that beautiful answer. Holy moly. All right, well, that was kind of